My MSLA printer prototype finally works! It prints, look at that! And it actually prints, and surprisingly without summoning a demon or tripping my circuit breaker, yet. This is my most complete MSLA printer prototype I've made so far, and it only costs around $40 or $50. What? The PCB I've made for this printer is awesome. It has everything, and I'm sharing the files as always for free. So go below and download everything: code, PCB files, 3D files, schematic, and so on. So guys, let me take you through my journey. Well, it all started with this, a simple Arduino Nano and a very small display. So small you actually needed a microscope and a lot of optimism to actually see if it's working or not. But then I went with this, a bigger display. But let's say that the resolution on this is kind of vintage, 320 pixels. I've seen better resolution on a potato. So the next prototype is the one that I thought it will make me the new Elon Musk of resin 3D printers. It had a 2K resolution display from a tablet, it was huge 10-inch display, but it was harder to set up than explaining to my wife why I have 50 kilos of resin in my garage. Since this was a tablet, the screen had so many filters that the UV light was actually asking for permission to pass, and the screen said, no, you shall not pass. But on the other side, on the small displays from the previous prototype, light passes through this like my money passes through AliExpress. Easy. Plus, the ESP32 and the tablet will randomly stop talking to each other faster than a divorced couple. To save money, this time I've made an all-in-one PCB. It has everything here, except maybe a coffee maker. It has its own power supply on board, power regulation, the ESP32S3, it has a step motor driver, an OLED display, it has an extra port for a next-gen display, the SD card reader, RGB lights for showing stuff, and also buttons. The display for printing is directly connected here, and the UV light as well, SSR and MOSFET for controlling the UV light, and a bunch of stuff more. It also has a buzzer to scream at me when I mess it up. The PCB is 100 by 100 millimeters and is made, as you can see, to be sandwiched in between with the PCB from the screen. So no extra connection, just sandwich it like this and you have your screen connected. Pretty neat, right? And this time the display that I'm using is of 7-inch and 800 pixels resolution, which is not the worst, but is getting better, and it costs around 20 bucks. If you also want to try and make this project, which I recommend you to do if you like the smell of solder in the morning, you can download my PCB files from below for free as always. Then you can go to PCBWay.com and click the Code Now button and add the size of the PCB and also the color. It's better to select the black one for this one because it will reflect less light. Then you save to cart, and on the next page you can upload the Gerber files that you have downloaded from my site and just make the order. And just like that, in a few days you will receive these awesome PCBs and you can start making your project with PCBs from PCBWay. The PCB looks awesome, and remember, this time you only need one PCB, not 3 as the previous prototype. So the price is even lower, only $5 for the PCB. I love how the PCB turned out. It was very professional, made by PCBWay, so thanks PCBWay for that. And I've designed this using Altium. Lately I've been using this software to make all my PCBs, and each time that I use it I realize how easy it is to make a PCB, which I also recommend you to try. You have the link below for Altium for a 30 days free trial without even using your credit card. Just try it out, and if you like it, maybe buy the entire software. It's very easy to use it. I've made the entire board to be 100 by 100 to just cost $5 for the PCB, and then start adding components. In my case, I already know all the components because this is a very old prototype that I've been upgrading each time. So I've added all the components. I had to make some manually made components, like for example the voltage regulator, because I didn't have the component for that, but the rest are there on the library. Import them with Altium and then make the schematic and start routing using the automatic routing, which is very good from Altium, or maybe some manual routing here and there. Then export the Gerber files and order it from PCBWay. So thanks PCBWay and Altium for making such a good PCB. So together with the PCBs, also download my schematic for these PCBs and let's start assembling. The only thing that I've changed, which is already corrected on the schematic, is the use of a buck converter instead of an LDO. And I switched to a buck converter instead of the 5 volts LDO because I prefer my components cool, not medium rare. I went with the ESP32S3 because I really have an addiction to more pins is better. It costs almost the same, so why not having more ports that I could later short circuit? For controlling the step motor, I'm using the TMC2208 for very silent movement. But if you love the nostalgic sounds of a screaming robot from 2012, you can use a cheap A4988. Works the same. To control the printer we have 3 push buttons, and by default it has an OLED display. Right now it has a very basic menu, but it works. But for a little bit more money I've added a huge upgrade. For the luxury version I've added an extra port for a next-gen display. In this way the printer looks like it actually knows what it's doing. And I've made the code compatible with both displays, because I really believe in equal opportunity displays. You can go to print, select the file or go back. You can connect the configuration and this is stored to the EEPROM. You can also go and move or home or stop the motor just as any other MSLA printer or see some information. So the next-gen display does the exact same job as the $2 OLED display, but it is a lot more user-friendly and looks a lot cooler. As you can see, the final board is quite modular, so it's easier to take everything out and change parts if you want. So make sure that you download the final code from below, read it well, and upload it with the USB connector to the ESP32. And also make sure that you install the needed libraries. Before we pass to the case design, which by the way in my opinion turned out perfect, let's just see a simple example of a printing process. Booting up. So we get the files from the SD card, I go to print. By the way, you can also use the other screen, but I'm using this. I have 2 files, I select one zip file. The printer will extract all the files on that zip file and start homing the printer. As you can see, home is the axis. The motor is moving till it detects my sensor, which is the Z switch S sensor. There it detected, but now very slowly it goes a little bit upwards and then downwards, because you want to make sure that the first layer is precise. Stops and now goes downwards till I touch it with the sensor. And now it starts printing. We have the first layer, as you can see, we have the first layer, which is the circle from the tower. Next layer, obviously the exposure time is not set to the exact values, otherwise we'll stay here a lot of time. I place it to just a few seconds. The first few layers will have 20 seconds of exposure time. So the printing process works. We have the time on the screen, we have the configuration. You can even enter if you want and set the configuration while printing, but I don't recommend you that. And you can stop it, pause it, and that's it. Let's just stop it. You want to cancel? Yes. Print cancelled and finish. So it works. It works perfect. I'm so happy with the results, because it's been like maybe 4 or 5 years since I've been making prototypes, and this one has no error yet. So yeah, I'm excited. Okay, so for the case, this is the 3D design that I've made. Now we have a bunch of files, but everything was well designed to add the structural support that it needs, but also look cool and also fit in place exactly where it needs. So let's start. This time the TFT display goes directly onto the top part of the printer. God damn. This time the TFT display goes directly onto the top part of the printer, and be gentle here, because if you drop it, you'll be back on AliExpress faster than saying shipping costs. The main case, as you can see this time, since it's not as big as the previous prototype, I can now print it in just one part, because it fits on a regular 3D printer. This time I've designed the printing bed support, but also the resin vat. This was 3D printed. I've designed the vat with 3 parts, because we have to sandwich in between the FAP film, and this must be very tight, so we need 3 parts to tie them together. So peel the film from the FAP film, put it on the first bracket, get the second bracket and make like a sandwich, and then you have to add it to the support and add a bunch of screws and tight it all around. And when I say a bunch of screws, I mean a lot of them. You'll be screwing till your hand will fall off. You will see that the FAP film will be just above the plastic of the vat, because in that way it will get in touch with the screen when printing. Oh, the ping of success. If it doesn't sound like that, it's not tight enough, and your print will look like a pancake. I've designed the bottom support with some air channels and a space for a fan, because 50 watts of LED inside of a plastic case sounds like a DIY oven. The LED matrix case was too big, so I cut it out, but I left the metal on the back, because this will help dissipate the heat a lot better. So now we should add some long wires to the fan, screw it in place here, then we take the matrix, we place it on top also with wires and make sure that it won't move, and then we take the lenses, which I also have to cut, and place them on top. Now that the bottom part is ready, we take the top part and we add the step motors with M3 screws here. We also add the end stop switch here with screws, and we also have an extra space for a USB connector for 12 volts just in case we add an air filter. Okay, now you see this groove here on the top part of the printer. That's for the PCB of the TFT display. That will go here because the entire pack of this PCB with the ESP32 PCB will go together here on this groove. Oh, and the next in display will go on a separated printed part like this. To get with only the transparent display, we have to remove all these filters. So get the display out of the PCB, then open the metal case of the display, take out the filters and keep only the display with the strip connector. Then we add the display to the top part of the printer and secure it in place with some tape. Make sure that you use some black tape so it won't reflect the light. Connect back the screen with the strip connector to the PCB. Connect the PCB of the display to the PCB with the ESP32. And now we can put it inside of the case and connect everything. Remember, it's 220 volts AC, so till everything is inside of the case, don't touch anything and don't connect anything, unless you want your hairstyle to match Einstein's forever. Okay, everything is well connected inside. I have the PCB. I've used some hot glue to secure the wires in place so they won't jump around inside there. So all I have to do now is to connect this screen, the UV light, and then we can pass to the Z-axis. By the way, both the top part of the case and the bottom part of the case has spaces for these insertion nuts, which I added with the soldering iron, and that's what I use to screw in place the parts together. Just a final test before I close everything up, and it works. For the Z-axis now is very easy. We take the 3D printed part and we add the rail with some screws and make sure that it can move freely. And then we take the other 3D printed part, we add this screw for the lead screw, another big screw that will be to connect the support for the bed, and then using these 4 holes and screws, we'll screw this here. Okay, Z-axis is in place, as you can see. It now rotates and goes up and down. I've added the screws. It's quite solid, so let's add the rest. Finally, for the printing bed, I've used a piece of aluminum that I've used for some engraving testing for my laser machine, but anyway, reusability is the best for this project. I've 3D printed this, and this will go to this other 3D printed part that will go like this here, and it will be held in place with a screw, and that will be the bed for printing. And there you have it, friends. Everything is in place, it's turned on. I have my vat, which by the way I have to tie this screw so it won't move. I have the printing bed, it moves up and down. You can read the files, so everything is set. For the first test, I still have to design a good pin that will touch the end stop switch, but for now I'm using this, works quite well, and yeah. So guys, it's finally ready after so much time. Let's test it out, and I hope that the vat won't leak the resin or the machine will give us the magic smoke. Hopefully. So that's why I'll make the first test without resin and then I'll add resin. So let's make a print. And we go to print, select this one and press yes. And now it's homing. As you can see, it's lowering the Z value, but I think it's a bit slow. So now I will just stop it and add some resin and start my first print. Okay, I can already see the tower there. We are at 43%. And there you have it. This part was printed on my own prototype of an MSLA printer that costs like 50 bucks. Can you know how proud that makes me? Finally, I have a working prototype. And it looks great. The quality is awesome. I mean, 800 pixels is not that much, but the pixels are quite small. With these prototypes, each time the price went lower and lower. Actually, if you mass produce this, the price could get even lower, because any screw, any module, any small part, you get a better price if you bulk buy it instead of just buying a separate part. Take for example the PCB. You pay $5 for these awesome PCBs, but if you were to make 100 PCBs, you pay just a few dollars, so you get the PCB for just a few cents. Imagine the cost reduction that you would have if you would make a lot of these printers. With my calculations, if you are not buying modules from AliExpress, but you would buy it in bulk from suppliers from China, for example, you could lower the price of this printer below $30. That's crazy. Let me take you to the list of improvements of this printer respect the previous versions. First of all, this printer is now using zip files instead of just a folder with all the pictures. That would occupy a lot of space, and not just that, but in this way with zip files it's a lot more organized. The code was a nightmare, but now this printer is able to unzip the zip file, get the files and use them. So now it's just one file for each print, so you can have multiple zip files on your SD card and everything looks a lot better. Then obviously the screen. Now it's 7-inch. In the previous version, the biggest that I had was this one, which is 3.4 I think, or 4-inch. Now we have 7-inch, and not just that, but now this is directly controlled by the ESP32, not as the Android, which was controlled using internet, which was crazy. And it's also a lot faster because it uses parallel communication to send each picture. So the process is a lot faster. Bigger, good resolution and faster. Another improvement is the use of a 50 watts LED matrix of UV light. Now I know it is of 220 volts, which is not recommended for consumer products, but in this way, since everything is inside of the case, it's quite safe. So 50 watts of that light is a lot, and that will increase the speed of the print a lot. One brutal update was the use of the S3 with dual cores. That is huge, because in this way, on the second core, we are making all the communication, the timers and the communication with the next-gen display and so on. And we have a free core to use it for the picture printing and the actual print of the printer. So in that way, the code is a lot more efficient with dual cores. Obviously, a huge improvement was the use of this next-gen display. Now the user interface is a lot better, you can control it a lot better. The code is compatible with both screens, so if you don't want to waste so much money on this screen, you can just use the OLED display, but this is a lot better. Now it took me more than 2 weeks to make this app, because there are a lot of pages and a lot of settings that you should do, but yeah, it's great and is a huge improvement. Other improvements are the use of smooth accelerations, and that's a lot better, especially for the FAP film to detach the print each time that you go up and down. I'm also storing all the settings now on the flash memory of the ESP32, so you can change that directly on the print and you don't have to upload the code once again if you want to change any settings. Just go on the screen, change the exposure time, the speed time, and it will get stored onto the flash memory. So each time that you turn off the printer, you will have the same settings. One huge improvement is that now the case is printed with only one part. In the other one, yet it was huge, but as you can see, it was printed in 1, 2, 3 on each side. It had like 10 or maybe 12 parts, and that moved a lot. In this case, it's just one part and it's a lot more compact. A huge improvement is that the supply is now on the board, so you don't need an external adapter on the outside that will occupy space. Just the power cord and the supply is already inside. Oh, and by the way, the PCB has UV light control with an SSR for 220 volts, but also a MOSFET for 12 volts. So if you just want to change the matrix to a 12 volts LED matrix, you can just do that without changing the board. And the PCB has an extra buzzer, and another improvement is the RGB light, which I'm not using it that much, but you can just show information with the light. When it's printing, it could be red, when it's on pause, it could be green, when it's homing, it could be yellow. So without making sound, you can just show information. And another improvement is now the future update of Wi-Fi, because in this case, I'm having a very good Wi-Fi on this SAP32 module, and it has an external antenna as well. So maybe in the future I can make an app and control it with Wi-Fi as nowadays printer have, and that will be a huge improvement for the future. By the way guys, you see that huge monitor that I have there, which I'm not using anymore? Well, my next prototype, it won't be with TFT displays anymore. I want to go huge, and that's why I have this module here, which is an ESP32 that is compatible with the VGA output. So all I need is a VGA adapter to connect to that screen and make a huge resin 3D printer. But that's a lot of prototype, and yeah, not sure when I'll have that video. but stay tuned for that. So guys, if you like my project, remember that everything is shared for free in the description. The PCB files, the 3D files, the schematic, the code, everything. I might even make a GitHub for the code because this is my best code for MSLA printer yet. So if you want to support me, you can just comment below or give me a like because that will help me a lot. As you have seen, YouTube is not promoting that much this kind of videos. So any comment or like will push my videos just a little bit. And also you can check my Patreon page if you want to support me and see some cool stuff. Thank you very much and keep up, you guys.